All right, so here's an example of going around the x-axis. So we're given a function x equals 4y squared minus y cubed, and x equals 0. So if you were to try to use Washer method on this and we're rotating around the x-axis, we need to be in terms of x. The problem with this function is you can't really get it in terms of x because you have a y cubed and a y squared here. So you're going to have a very, very difficult time doing this. So this is an example I was talking about earlier where you have to use shell method in order to find the volume created by taking that area, that region, and rotating around the x-axis. So we are going around the x-axis, so we need to be in terms of y. We're using the shell method. We're already in terms of y. So that's why we want to use shell method here. And we want to take remember, a length parallel to the axis of rotation. So x-axis is horizontal, we need a horizontal line. Okay? So if we look at this and we rotate around the x-axis, we need to be thinking about what our radius would be. So from the x-axis to wherever you draw your line, that's going to be the distance given by y, the y value that you're at. So we can go ahead and we can set up an integral. So 2 pi times the radius, which we just said was y, times our height. So our height from the y-axis to our function is just the function itself. So we can go ahead and write our 4y squared minus y cubed, and then dy. And then we look at our boundaries. So we are between here and here. So between y is 0 and y is 1. So 0 and 1. Again, here's the setup, and that's the most important thing here. But go ahead and either throw it into the calculator, integrate by hand to get some practice, and we will take a look at something off of the x-axis or the y-axis in another video. So that is it for this video.